Hello students, so welcome to the lecture number 19 of chapter 7. In lecture number 18 we have solved the first question from the exercise 7.3, and in this lecture we may solve one or more than one question depending upon the time taken by each question. So without wasting time, let's start with the second question from the exercise 7.3. Okay, so the question number 2 is AD is an altitude of an isosceles triangle ABC. So it is given that AD is what? It is an altitude. And second thing is triangle ABC is an isosceles triangle. Okay, so let's draw a isosceles triangle first. So ABC is an isosceles triangle. Okay, now in this triangle it is given AB is equal to AC. So this side is equal to this side. This is given. And AD is an altitude. As I have told you, tell me what is the actual meaning of altitude? We have discussed it. What is an altitude? Let's see. Suppose altitude. Suppose there is a line MN. Okay. And there is a point O which is above this line. Now, if we draw a line OP such that OP intersect MN at an angle 90 degree. What we have done? We have drawn a line OP which intersect MN at an angle 90 degree. Then what we can write? We can write OP is perpendicular on MN. You know it. Now this perpendicular is also known as altitude. So the other meaning of altitude is perpendicular. Did you get this? So the other name of altitude is perpendiculars. And here OP is perpendicular to MN, or you can say OP is an altitude. Understood? Let us take it for a triangle. Okay. For example, let us take it for a triangle. If it is a triangle MNO. Okay. Now, if we want to draw a perpendicular line on NO, then we have to start drawing the line from which point? Tell me. From its opposite vertex. Okay. If we want to draw a perpendicular line on NO, then we have to start drawing the perpendiculars from its opposite vertex. What is the opposite vertex? N. So let us draw a perpendicular line. Suppose this is your MA. Okay. So this is perpendicular, means it is 90. Clear? So we can write that MA is perpendicular on NO. Similarly, if we want to draw a perpendicular on this side, on which side? On this side, MN. Then we have to start drawing the perpendicular line from its opposite vertex. That means O. So let's draw a perpendicular line. Suppose this is the perpendicular line. OB. Okay. So this is 90 degree. This is also 90 degree. So OB is perpendicular on MN. Right. Next. If someone wants, I will draw perpendicular line on this side, on MO or OM. Then from which vertex he or she would start drawing? So we'll start drawing from the opposite vertex, that means the vertex N. So let's draw a perpendicular. So this is NC. So this NC is perpendicular on OM. This is clear? So this is 90 degree, this is 90 degree. You can write NC is perpendicular on OM or MO. So here we have found three perpendicular lines on the three sides of the triangle. Now these three perpendicular lines are also known as altitudes. Okay. So the altitude is nothing but the perpendicular line on the side from a opposite vertex. Okay. So what is altitude? These are the, write it down. These are the perpendicular line on a side of triangle. Okay, on a side of triangle and drawn from its opposite vertex, and which is drawn or which are drawn from its opposite vertex. This is important. Now to draw a altitude on any side, you have to start drawing from its opposite vertex. Okay, so here you can see a triangle at most has 3 altitudes. Here the 3 altitudes are MA, OB and C. MA and OB and C. Okay, this is clear. The concept about altitudes is clear. Next thing, now vividly see this figure. What you can see? As the 3 altitudes MA and C and OB are passing, they intersect each other at a common point. Did you see this? All the 3 altitudes intersect each other at a common point. What is the name of that point? The name of that common point is orthocenter. O-R-T-H-O, orthocenter. Right? So let us write its definition. Orthocenter. So what is an orthocenter? The meeting point or the common point at which all the 3 altitudes meet each other is known as orthocenter. Okay? A common point at which all the 3 altitudes of the triangle what? Meet each other or intersect each other is called orthocenter. Write it down. Okay? This is all about altitudes, and the meeting point of all the altitude is known as orthocenter. Now coming back to our figure. In this figure it is given ABC is an isosceles triangle where AB is equal to AC. Okay? And here also there is an altitude AD. Okay? So let us draw an altitude. Suppose this is the altitude AD. Now this AD is an altitude. It means what? It means what? AD must perpendicular on BC. This is the meaning of altitude, isn't it? Now it is also given AB is equal to AC, since it is an isosceles triangle. If AD is perpendicular on BC, then can we write this angle is 90 degree and this angle is 90 degree. Okay, so implies ADC is equal to ADB is equal to 90 degree. This is done. Next thing, what we have to prove? We have to show that AD bisect BC. AD bisect BC. Okay? Bisect BC means what? What is the bisector? Line bisector. A line bisector is a line which divides another line into 2 equal halves. So we have to prove that AD bisect BC. That means we have to prove this distance or this half is equal to this half. Okay? So we have to prove BD is equal to C. This is the first statement. Second thing, AD bisect A. AD bisect which one? This angle A. It means we have to prove that this is the angle bisector, or this half, this one is equal to this one. That is the angle bisector. Or you can say we have to prove BAD is equal to CAD. Right? So let's prove for the first statement. Proof 1. Here we have to compare 2 triangles, triangle ABD and triangle SCD. Okay? So let's compare between triangle ABD and triangle SCD. How they will be congruent? Let us find the conditions here. Here, for triangle ABD, AB side is equal to for the triangle ACD, AC side. This is given because ABC is an isosceles triangle. Okay. Next, this angle. Which angle? This angle. This angle is 90 degree, and for this triangle ACD, this angle is also 90 degree. So ADB is equal to ADC is equal to 90 degree. ADB is equal to ADC is equal to 90 degree. Third case is you have to write the reason. The reason is that AD is perpendicular on BC here. And the third case is for the triangle ABD, AD is a side, and similarly for the triangle ACD, AD is also another side. So AD is the common side to both the triangle. So AD is equal to AD, common side. Now we have found three conditions here. Now let us find which congruency these three conditions satisfies. Okay. So let us find for the triangle ABD. In the triangle ABD we have found this angle. So this angle means R means right angle second. The opposite side of the right angle is known as hypotenuse. And here we have chosen this side. See here. So this stands for H. Next thing. AD side is common to both the triangle, and this stands for side, right angle hypotenuse side. So by RHS congruency, what you can write? These two triangle ABD is congruent to the triangle ACD. Okay, so now we have proved that both the triangle ABD and ACD are become congruent. Okay, and now since these two triangles are congruent, then according to the exam 7.2, we know if any two triangles are congruent, then their corresponding sides and corresponding angles are equal. Now, for the triangle ABD, BD is a side, yes or no? Yes. For the triangle ACD, CD is also a side. Understood? But what we have proved? We have proved that this triangle is congruent with this triangle, and these are the corresponding sides of this two congruent triangle. Then according to exam 7.2, we can write BD is equal to CD by exam 7.2. So we have proved that BD distance is equal to CD distance. It means D is the midpoint of BC. It means AD is the bisector of BC. This is proved. So we have proved the first statement. Here you can write. It means AD is the bisector of BC. Understood? So the first statement now has been proved here. Next we will move for the second statement. Let's prove it. So you can take a screenshot of it. I will now erase it. Okay. So since we have proved that two triangles are congruent, now I have told you that if any two triangles are congruent, then their corresponding sides as well as corresponding angles must be equal. So this angle is the corresponding parts of which triangle? ABD triangle. Which angle? This angle, BAD. So we can write BAD, and this angle is also the corresponding parts of this triangle ACD, CAD. And now by exam 7.2, these two corresponding angle must be equal by exam 7.2. So we have found that this angle is equal to this angle, or this half is equal to this half. It means this line AD bisects the complete angle A into two equal halves. So AD is the angle bisector of angle A. Implies AD is the angle bisector of angle A. Understood?